Module 1, Measurement, Units, and the Scientific Method. More complex unit conversions and problem solving. Well, now that you are more practiced at the factor label method, let's use it for more complex problems. Don't worry, this method works no matter how weird or challenging the units you are given. All you need is a conversion relationship between the unit you have and the unit you want, and you are good to go. So say we have a volume of liquid that is measured to be 4,523 centiliters. You want to know how many kiloliters that is. Well, you don't have a direct relationship between centiliters and kiloliters, but you do know a relationship between centiliters and liters, and you do know a relationship between liters and kiloliters. So let's just do our conversion in 2 runs. First, centiliters to liters, and then liters to kiloliters. We'll start with centiliters to liters. What do we have? 4,523 centiliters. Let's make that into a fraction by placing it over 1. Now, what is our conversion factor between centiliters and liters? 1 centiliter is equal to 0.01 liters. So make that conversion into a fraction so that the centiliter units cancel. Now we can multiply the 2 fractions together, canceling centiliter units and getting 45.23 liters as a result. Okay, now let's convert our liter measure into kiloliters. What do we have? 45.23 liters. Make it into a fraction by placing it over 1. Now, what is our conversion factor between liters and kiloliters? 1,000 liters equals a kiloliter. So make that conversion into a fraction so that the liter units cancel. Now we can multiply the 2 fractions together, canceling liter units and getting 0.04523 kiloliters as an answer. If you understand how we got there in that 2-step process, you can see how we can shorten the pathway into 1 by taking our original given unit and multiplying it by our first conversion relationship and our second conversion relationship. Cross out the like units and we still get the same answer. In this problem, we didn't have a relationship between the unit we were given and the unit to which we wanted to convert. So we had to first convert to the base unit and then from that base unit to the final unit. Let's try another one. You measure the mass of a slice of bread as 0.025 kilograms. What is its mass in milligrams? In this case, again, we don't have a direct conversion factor between kilogram and milligram, but we can do a conversion factor from kilogram to gram and then a conversion factor from gram to milligram. First, let's convert kilograms to grams. So what do we have? Our measurement is 0.025 kilograms. Place it over 1 to make it a fraction. The relationship between kilogram and gram is 1,000 grams equals 1 kilogram. So set that relationship up so that kilograms cancel and then multiply to get 25 grams. Now we still need to get from grams to milligrams. So what do we have? 25 grams. Set it over 1. The relationship between those 2 measures is 1 milligram equals 0.001 grams. Set that relationship as a fraction so that grams cancel out. Can you see that the only unit we have left is milligrams? And that's what we're looking for. So multiply the numbers to get 25,000 milligrams. Again, you can do this 2-step problem as 1 step using both conversions in the same equation. The more you practice this method, the better you will get at it. But can you see that it is just a basic series of simple steps that work no matter what units you are using, as long as you have a relationship between those units, whether it is directly or using a few conversion steps?